Tell me if it's not clear, shaky, it's not loud, huh? If it's not loud, tell me. Okay? Okay, I'll use this one because this one is uh this is working. Okay, let's go. Tomorrow's long quiz covers lesson 2 and 3. Am I right? Okay, the first one is the remainder factor theorem. Remainder theorem and factor theorem, and its proof. And currently we are in the rational root theorem, no? Rational root theorem. So we continue our rational root theorem. Okay, let's have this. No, I gave this one for those who were vaccinated last week Tuesday. Okay, this is their assignment. And I gave you that also in the GC if you recall, right? Okay, sige. Let's make it big now for you guys. Medyo maliit pag Excel eh. Okay, assignment. Find all possible rational roots of this polynomial. And then, of course, the real roots should be determined. They have, okay. If up to now you are confused, no, on how to determine the P and Q of this polynomial, you have a problem, no? Okay, after the monthly exam, still, no, we have this polynomial and it becomes function now wherein we graph, no? If you have problem identifying the Q, the P, and the PQ here, you really have a big problem. Okay, P here it's 12, and then 2 it's the Q. And then factors of 12, how many are they? There are 12 factors, it says there, no? Again, how many factors are there? I do not mind checking you there in your video call, no? I will not waste time, really, no? That's not me. It's up to you if you listen. If you're not there, it's up to you. 12 is there. Factors of 12 are these ones, you must know, no? And then we include the negative. Okay? Yung mga iba sa inyo, yung solutions nyo, even if it's assignments, I deducted, no? 1, 2 points. Why? Because I'm not seeing positive and negative, no? Okay, I told you that there must be positive and negative signs before the number. Okay, how many are there? It's 2, 4, 6, 8, 10, 12. Okay, 2, 4, 6, 8, 10, 12. 12 factors for P. Why? Because of the positive and negative. And then 4 factors for 2. Because it's positive, negative 1, positive, negative 2. How many are they? It's 4, no? And then combination of P over Q. Okay, paulit-ulit na lang si Sir Romel. Okay. So for this one, and then this one divided by, and then if I were you, please follow Sir Romel, no? Divide the numerators by 1. It gives you the whole number. The numerators themselves, no? Will appear there as your whole number. Did you get that? And then afterwards, your rational. Okay, it seems the rational that we are actually solving for the rational root theorem is the fractions, no? A form of fractions. Yun kasi yung pinaka, what do you call this one? Purpose of the rational root theorem. Did you get it? For synthetic, it's so easy eh. Parang it's whole number for synthetic, no? Naintindihan? Okay. So for this one, the rational root theorem, oh, sorry, the rational or the fractions, it's 1 over 2, and then 2 over 2, it's 1. Go back here. 3 over 2, and then 4 over 2 gives you 2, huh? Mind you. Okay, you do not write there. One of those rational roots of fraction is 4 over 2. Hello, baka hindi pa kayo marunong mag-simplify, ha? Or mag-divide. 6 over 2, positive, negative 3 is there. 12 over 2, positive, negative 6 is there. 12 over 2. Okay, next. So these ones are your possible root or rational roots. And then Here we go, no? 1 and negative 1, 4 and negative 3 over 2. Okay, sige. I've noted lang, no? I've noticed on, sorry, tanggalin natin to. It's not necessary anymore. Okay, I've noted, no? For Anna Faith and OC, they got perfect, and the boys did not do your assignment. Huh? You did not do your assignment. Okay, but I've noticed, no? Your synthetic division appeared many times. Why? Of course, you are consuming the possible root or rational roots, no? How many are they? It is but 16, no? 2, 4, 6, 8 times 2, it's 16. Okay. So they assumed solving for the real roots, no? For the rational roots, how many times? Okay. It, it took them to use how many times the synthetic division? It's 8 or 16 times rather, no? Okay, but for me, I'll just use this one, okay? Okay, so these ones are the constants of your polynomial. Make sure they are complete. Okay. And make sure also we are reviewing now because tomorrow it will be a long one. Okay. Make sure also that if you do not have this polynomial in this form, it means to say it's a range from lowest, say that again, from from highest exponent to lowest. Make sure to arrange it. If not, you'll be going the wrong way, no? You'll solve it the wrong way even if you use a synthetic. Make sure. And if there is term that is missing there in the polynomial, make sure also to put your zero, okay? Okay, zero for the missing term. It must be complete. 4, 3, 2, 1, and then the constant that do not have the variable. That must be complete. Okay, likewise in here, okay, constants of those are 2, negative 5, negative 4, 5, and 12. Okay. So, yun yung sinasabi ko, no? That's what I'm referring to. You insert a zero here if term there in the given polynomial is missing and arrange. Huh? Don't forget that. Okay, let's go now here. If I'm a student, actually, I begin with 1, no? Always, and negative 1, and then I increase. Okay, for instance, for this one, I started with 1. Okay, it gave me 0. Okay, synthetic to, ha? Okay, know how it works. And then if you notice also, I do not want to repeat these ones anymore, no? I reduced 2, negative 3, negative 17, negative 12. And then negative 1 is next, no? After 1. 1, positive, and then negative 1. I did not write repeatedly, no? I did not write repeatedly these ones, it's constants, no? Since this is 0, you can have these constants, no? From here. And then try negative 1. Notice that if you try synthetic for negative 1 for these ones, no? It will result to 0 also. It's there, no? Notice that. Okay, it's making your life so easy. Reducing the writings you make, no? And then afterwards, notice that 2, negative 5, and negative 12 are just but giving you the values of A, B, C, no? That is reminding you that is a polynomial that is quadratic. Okay? Did you get it? Quadratic, no? Why? Because it's x squared minus 5x minus 12. So this one is a quadratic. Okay. Take note. This synthetic is giving you a number, but, okay, there seems to be one there that is a rational, a fraction, no? How do you do that? Of course, by using the quadratic formula. Okay? Okay. So bear this in your mind now. That quadratic formula is the easiest method for you, no? For looking for those other roots. For this one, it's giving you 4 and negative 3 over 2, no? 3 halves. Negative 3 halves. Okay, rational obviously is there, no? Okay, but how, no? Quadratic formula is the easiest way, no? If you can factor this, then well and good, no? But it's really hard, no? Trial and what do you call that one? Trial and error, no? Tama ba yun? Yes, it's a trial and error, no? If you want this factored out, no? A tic-tac-toe maybe for this one. I do not know how you deal with that one, but we've learned about this, no? When you were in grade 9, there are four methods treating the quadratic equation. This one, right? What are those? Can you give me one method, Hannah Faith? There are four methods in solving for the roots of the quadratic equation. Okay, one is,
Um,
of course, one is quadratic formula, right? Okay, there are three na lang. Yes, katakutan.
Perfect square trinomial po. Is that included?
Okay, that is a form, no? For the trinomial, it is a perfect. It could be done with factoring, no? Methods by factoring. Okay, one more. What about a boy? Sige, a boy. Can we have some? Okay, we have quadratic formula, no? It's there now. Factoring seems hard because amongst the four methods, I think quadratic formula is so easy, although it's long, but it's good for finding the root that is a fraction, no? What else? Factoring, quadratic formula, and sum is there? Okay, nakalimutan na nila. Okay, sige. I'll give it to you. The other one is extracting the square root, no? We extract the square root, it's easy, no? Okay. There is no bx term. It's ax squared only and c, the constant. And the other one is, of course, the completing the square. That's very hard, no? That's the hardest among the four. And I think the easiest could be extracting the square root. It depends, no? Okay, if you can distinguish that. But of course, the long method, it's not a long method, but it's giving you actually the rational, no? And including the irrational root. It is the quadratic formula. Okay? I hope you recall that, no? You are recording it. Okay, let's go. So for this one, obviously you've read this one. It's giving you 4 and negative 3 over 2. How, no? Okay. So the value of A there, it's of course it's 2. A, it's 2. Value of B here, it's negative 5. So this is a constant, a negative 1, no? Sorry, a negative sign rather. But B must be replaced by a negative 5, no? Okay, you do not touch negative 5 there before the B because it will give you another sign, no? Other sign. Okay, B squared is there is a negative 5 raised to 2. What about letter C? It is but a negative 12, no? A is 2. So again, this one is giving you the ABC of a quadratic. Okay? Okay, again, it's like that. And then go. Okay, how to operate this, no? For operating a radical. 25 plus 96 is 121. Of course, the square root of 121 is 11. A negative and a negative 5 multiplied together, it's giving you 5. A positive 5. 2 times 2, your denominator is there 4, right? Okay, again, the radicand inside, it's 121. Square root of 121, it's 11. And this is one, sorry. And this one is giving you 2, no? Two rational roots or two numbers rather. Why? Because of the positive negative 1, that is the property of your square root, no? Remember, square root is the only, what do you call that? Nth root, no? That is giving you a positive and negative. No more, no? It's not the the fourth root, the sixth root is not. They're not giving you positive and negative. signs, no? There are two for the square root, nothing more. Next, so if it's giving you two signs, split them, positive and negative. This makes it 16 over 4. This makes it negative 6 over 4. That's why negative 3 over 2 simplified from here, and then 16 over 4, 4 over, sorry, 4, and negative 3 over 2. Okay, these are your roots now. Root 1, root 2. Always write this one. Okay, be organized. Next, I do have 1, negative 1, 4, and negative 3 over 2, right? Okay, and then I can finally list this one now. Okay, take note, no? Let's go here. Let's analyze this one, no? Okay, it's a trial and error, really, no? What if you were not following, no? If parang you guess only, no? It's your guts telling you it's not 1 and negative 1. I think it's 4. Okay, let's try 4, no? And you did not try 1. It's 4. What happens? It gives you 0, and then 2 and negative 3 there is there, no? Okay, there. Okay, what do you observe, no? This is the Q, this is the uh rather it's this is P, this is Q. It's giving you the other root, negative 3 over 2. Okay? It's like by a chance, no? You didn't actually use 1 by a chance, you solved 4. You see, check the P here and the Q here. It's saying there is a root that is negative 3 over 2 because of this, no? Okay. Did you get that? Okay, if you try negative 1, giving you again, you go back to 2 and 12, no? 12 and 2, 12 and 2. Likewise, it's the 1 also, no? It's telling you. If you try negative 1, it's giving you again, it's negative 12 and 2, no? See the repetitions of the Q or the P and the Q. The P and the Q, the P and the Q. Okay, there's a pattern, really, right? Okay. So it means to say there is a way really of what do you call this one? Reducing, no, the chances of these ones to be uh considered really the rational roots, no? Okay, because you are wasting time. You will be wasting time, no? So take note of those, no? I told you that. So the PQ here are very important. 12 2, 12 2, and then a 12 2 there. They are very important. But nevertheless, if you it happen that you solve it this way, okay, you must trust your quadratic formula. It says, okay? Okay, let's go now here. So I have these roots. Okay, we all know these ones now, no? Roots, and then these ones are your quadratic, sorry, your factors. X minus 1, x plus 1. Okay, x minus 4 for 4, and 3x plus 2, or x plus 3 over 2 for negative 3 over 2. Okay, we all know that, right? We do not waste time for that one. Okay, next example. Can you go all? Okay, I need not to actually uh, ask you to actually screenshot that. That is in your GC. Go to page 79 of your textbook, and let's go to of course examine, no? Let's go examine what happened there. I do not like the textbook. For the other textbooks, they are they are clear. It's very good uh, presentation. But for the textbook, I do not like. Okay, let's go now to your page 79 example 2 and make it large again. Okay. Pag hindi po malaki ang inyong screen, If your screen in the Google Meet is not large, make it zoom it. Okay, zoom out. Okay, so there are sorry, the P and Q are 10 and 1 respectively, no? But there's no missing. 4, 3, 2, 1 should be arranged. If there is missing for synthetic, 0 again, ha? Make sure 152 na tayo. Okay, so it's 10, right? And then 1. And then enumerating everything, positive 1, 2, 5, 10, and of course the negative also. And this one, okay, may tawag dito eh. Sa ibang, may tawag dito sa ibang sa textbook eh. Coloradi ang tawag diyan. Pag sinabing corollary, corollary, no? Pag sinabing corollary, take note of your Q, no? The Q is one, imaginary one. See? And if your Q is one, there's no way that it's giving you a fraction. Why? Because imaginary one, no, is your denominator. It's giving you a whole number, no? Okay. It's easy, no? Okay. But take note of this, no? As we go on, take note. Okay? It's giving you possible rational roots that are whole numbers, but find out, no? What's going on. Okay, let's go. Factors of 1, of course. 1 and negative 1 only, no? Okay, so it's complete. Okay, there are but, hindi yan 16, ha? Okay, hindi ko lang napalitan. There are 2 factors for 1. There are 2, 4, 6, 8 factors of 10. And then, of course, there are but 2, 4, 6, 8 also factor forms. Okay? Baka sa pag-count lang ng factors, hindi pa kayo marunong, ha? Okay, why? Because of this, right? Okay. Your denominator is 1. Possible rational roots. I enumerated this one, no? Okay, possible. Okay, and then rational roots, which are whole numbers, are coming from that one. And let's find out, no? Why do we have these irrational roots there? Okay, sige. Are you ready? Okay, so we use these possible rational roots, okay? Okay, we go synthetic. Okay, again, in the textbook, what do you notice? It's making use of the process that is remainder and factor theorem, no? And or, no? Remainder and or factor theorem. Anyway, it's the same process, no? Okay, for remainder, there must be a value. It's remainder value. And then for factor, it must be a zero value, no? We all know that. And then you notice there in your textbook, it is using, okay, the factor or remainder theorem, no? Okay, I will not open that anymore. It's a waste of time. Okay, but for me, I use synthetic. It's okay, no? If you use that also. But try to actually differentiate what's the difference, no? When you use the process of the remainder and or factor and a synthetic. Okay, let's go. These are the constants of our polynomial, right? Okay, I'm making sure that I will not use zero, no? I will not insert any zero. Why? Because this is complete. Okay, that's okay. And then rational roots, no? Okay. It, it will happen really that we will start with 1. But take note, no? 1 and 10 is your hint. 10 and 1. Of course, 1. Okay, if you are fast, there is a remainder. But what about negative 1? There is still a remainder, right? And then you go up. 2. Okay. There is a remainder. For negative 2, it's 0. No, you're increasing. So for me, amongst the possible rational roots, I tried 1, negative 1, they failed. A positive 2 failed, a negative 2 is okay, no? So you should be fast. Okay. Okay, later on kasi, ang pangit kasi ng textbook niyo rather, no? If you go to page 117 now, the Descartes rules of signs, it's telling you really, no? The signs of your rational roots. Andun yan eh. Ang layo niya kasi, ang pangit talaga ng textbook niyo. I do not like it. But I will not insert Descartes' rules of signs, no? Okay, after this lesson, if you want to jump there, you can jump there if you want. But I will not jump there, no? That's 3 lessons, 4 lessons above, no? Or rather, uh, if you forward, no? If we, what do you call this one? Uh, fast track, no? Mabilis. Okay, layo kasi ng 117. Okay, let's go now here. So I find -2. That is 0, no? My remainder. And then, of course, you go to negative. After -2, it's 5, no? Okay, in here, you're wasting at least 3 numbers, no? Okay, that's -1, 1, and of course a 2, and a 2 in here, no? And then right away you have 5. Okay, you will not go to 10 anymore. Why? What is that number that is telling you really that you do not jump at +10 and -10, no? What is that? It's not a number. We go here, no? So I told you that. I told you about the P and Q here and the P and Q here. It's also there, no? Notice, no? If I have -2 here, from 10 to 1, this constant P and Q, it was reduced, no? Okay, specifically for P, no? 10 here became 5. Okay, so it means to say that 10 is no longer one of the possible rational roots. Did you get me? Okay, from 10 to 1, okay, we considered it 1, 2, 5, 10, okay, including the negative, the possible rational roots. But then, I've noticed that if you found one of the whole numbers, or we'll say this is integer to be specific, okay, again, okay, again, no? I'll make it not difficult for your exam tomorrow or quiz rather, long quiz tomorrow. Hindi ko po ko kayo pahihirapan, no? If it's like how many roots, possible roots are there, and then you'll be wasting your time, no? Really, if I will not tell you the technique in here. Okay? Okay. The technique is that once this is reduced, this one, no? Okay, this is the sum. Actually, of this one, no? This two. Notice that 10 and 1 is reduced to 5 and 1. It means to say you reduce choosing, no? Or you reduce considering the other possible roots, no? Possible rational roots. Like here 10 is existing, here 5, it's 5 already. Okay? So therefore, this one, okay, this one, let's say, no? What's next? Okay. So you do not consider jumping, baka you might jump into having 10. No, you do not jump into there, into that 10. Why? Because this 5 and 1 is telling you that 10 is no longer a possible root. Did you get it? Okay, thumbs up. Okay, thumbs up. Did you get it? Thumbs up kayo. Kasi kung hindi, hindi ako naintindihan, no? Salita na lang ako Tagalog, pero andiyan si Yampong. Okay, it's really hard to actually speak English. I'm so fast here, and then I do not know if all of you understand. Okay, really understand. Okay, there is some there. Okay, let's go. So it reduces, no? So 5 really qualifies. Okay, -5, of course, it's giving you a root. I'm sorry, a remainder, right? Okay, it's 5. And then what happened now? You notice also that P here and Q here is reduced, no? 5 and 1, no? Okay. It means to say, really, 10 and negative 10 is out of the way, out of those choices. They are really not part of the choices anymore. Okay? Because after trying 5, it gives you these ones, and it's P and Q there. Okay, so it is reduced now. But, okay, let's see now, no? What happens there? Okay, you do not try again, no? Okay, because it will be a waste of time. You have negative 1 and 1 there and saying it's possible that 1 and negative 1 is really a root. And then you're wasting your time, no? Okay. You're wasting really your time if you keep on trying to have it in a synthetic. This one, no? 1, negative 2, and negative 1, no? Why? Because at first you tried it 1, there's a remainder negative 1. It really is. No, do not try it anymore, no? Okay, do not try it anymore because you've tried it already. Okay, and then what happens here? It really is suggesting that you use the quadratic formula. Okay? Why? Because in using the quadratic formula, it is giving you a irrational, no? An irrational number. Though we are actually using the rational root theorem, no, to look for the rational root really, no? But for this quadratic formula, it is amazing, no? Really, how it gives us irrational. We're not looking for irrational, really, no? We're looking for a rational root, no? Of a fraction, fractions could be, no? But how do we actually solve for irrational, no? Out of the synthetic and even your remainder theorem or factor theorem? They cannot. They will not help us. Unless, of course, you recall how quadratic formula works for you. Did you get it? Okay, it works, huh? Don't forget that. Okay, so for this one, okay, A, B, and C. For as long as you know how to determine A and B, C value there, you can apply the quadratic formula and check for yourself, no? Okay, it's giving us 1 plus the square root of 2, 1 minus the square root of 2. And the value of that in terms of decimal number is this one, no? Okay, uh, it is really irrational, no? When you say irrational, uh, it can never be expressed in a fraction, no? Okay, it's not a repeating decimal and or what, or a one, what do you call this? The decimal place uh, number, which is uh, the very like of the very like, 1/2, no? Okay, so it's not. 2.41 and 0.421. But there's no way for you to be actually checking your work, no? There's no time, no? If you want to have this 1 plus square root of 2 as one of the roots coming from this quadratic formula, there's no way, no? It will eat your time. Okay. 1 minus the square root of 2, there's no way, no? But if you want to have this one, okay, 2.41421 in here, let's try. Okay. 2.24, sorry, 41421. Okay. 2.41421. It says there. Oops. Okay, it's giving you a 0. Okay, this one, no? And then the other one is 0.41421. It's giving you a 0 again, I think. Oh, no, it's not. Okay, let's go. Because of this. Okay, sige. But for this one, I think it's giving you. Okay. Hindi. Why? What's the problem? Okay, I think it's one of the factors, but it's not one of the roots. Okay? So for 2.4121, it works, no? You notice? Okay, it's giving you 0, no? But there's decimal, round it off to 0. Okay, for 4. 4 0.41421 it's not. Okay. So just try that one, okay? Negative 2 and 5. Okay, just try that one. But for your case, no, since you are not using Excel, you do not know how to use this, do not attempt, no? Okay, you go mad. Like Sir Roman. 2:07, 3 minutes na lang. Okay, so this now is the irrational, but it's part of it, huh? Mind you. Okay, 1 plus square root of 2 is here now, no? So for rational roots, it's 2 or negative 2 rather and 5. And then we add also a root or roots which are irrational, huh? 1 plus the square root of 2, 1 minus square root of 2, okay? That were solved using the quadratic formula. And then, if you have the factors of these roots, okay, dali lang, ha? Equate it first is x. And then this one also, if you notice what I did, equate these ones first to x, no? This one. And then, take note, that is irrational roots. It's not solely it, no? And sorry, it's not solely irrational that is the square root of 2. Take note that there is 1 plus and then 1 minus, no? They cannot be you cannot separate them, no? It cannot be separated, okay? That's why, if you notice, there is a parenthesis, okay? So parenthesis is 1, and then that's the time because they're inseparable, right? Okay. X, and then transpose this irrational root, this one, no? Irrational root, and it becomes a negative, and this is your factor. And then this is one is your factor. X equals, okay, and close it first with the parenthesis. Naintindihan? Okay. That is why if I'm going to be asking you, is this factor, okay, is this factor part of that polynomial? Yes or no? Okay. You undergo this process, no? Solve for one integer that is a positive, one integer that is a negative, and then you go to your quadratic formula and then finding out, no, that there is really a root that is 1 plus the square root of 2 and 1 minus the square root of 2. Okay. Naintindihan? Okay, that's easy, no? Okay, sige, let's go. Titan ko lang ito. Okay. It could be zoomed out for you, no? Okay, so sige. Screenshot this one. Okay, take note of this one, ha? This is the emphasis of this today's lesson. 5 and 1, 10 and 1. Okay. For you to reduce, no, your chances, no? Now you do not need to go and do the synthetic of all the possible rational roots. Kuha. Okay. But we do not know, no? Okay, where are these integers, negative, positive, located? If there are really possible rational roots there, no, there are plenty. It's really, no? Um, have to actually try them. Okay, sige. Okay na tayo? Okay. 211 na rin, no? So remember, no? Uh, this one is your learning objectives now. What matters is that for 3 and 4, or 2 and 3 rather, the factor theorem, okay, there is but an x minus a divisor, no? Okay, and remember what is x minus a is telling you about, no? It's giving you x, a value, because that is the root might be, no? And then you can test that in a remainder and factor theorem. Okay, did you get that? Okay. So do not hate no the factor remainder theorem. It's not like a synthetic, although they're giving you the same values, but when you operate them, they're not similar. Okay? And for the rational root theorem, okay, it's more complicated actually, no? It will be not complicated anymore if I'm going to be actually teaching you the Descartes rule of sign, rule of signs, it says there in page 170. Okay, that's easy, no? Dali na lang yan. And if you notice also, no, I do not give word problems here. From 1, 2, 3, 4 lessons, 1, 2, 3 lang pala. 1, 2, 3 lessons, I did not give you any word problems yet. Why? Because we will have that tomorrow. Ay, tomorrow pala is long quiz. Partly, no? Because I'm going to be actually teaching you the new lesson. It's lesson 4, no? It's the quadratic equations and its roots. It will be easy. No word problems yet. Bakit po kaya, no? Why? Because I do not want to actually confuse your mind, no? I will not give you complicated, complex learning when we are to learn concepts of this because it's so complicated really, no? If I give you word problems, it will be more complicated to you, okay? Because my very objective is to teach you the concepts of these ones, from synthetic to having the remainder factor and the rational root, no? They are really related to one another. Did you get it? Okay? So for tomorrow's quiz, long quiz, good luck to all of you. Okay? Okay, Messenger ulit tayo. Messenger, you give me present. Okay, if you do not have present word there as for attendance, you're absent. Okay, bye-bye. Ano, you're tired.